We're going to look at doing the midpoint, trapezium and Simpson's rule in Excel for a particular function. The first thing we're going to do is I'm going to create a table of x values versus function values. So I want to create a midpoint rule estimate up to M8. My function is going to be equal to 2x to the 5, and I'm going to be integrating between the values. My lower value is going to be a equals 2, my upper value is going to be b equals 4, and I want to generate enough x points so that I can calculate M8. So I have to do the b value minus the a value, and I'm going to divide that by 16. So that ensures that I've got enough spacing for my x values. My first x value is going to be 2. My subsequent x value is going to be 2 plus 0.125, which is just the h value we have up here. I'm going to take that cell and I can now copy that down until I have the value 4. In this column I'm going to do 2 times this value here to the power of 5, and that gives me the value of the function at the point 2. And again I can just copy that down to get the value of the function at those particular points. I want to calculate M1, M2, M4 and M8. Now M1, in that case the width of the rectangle is going to be 2, because that's the distance between 2 and 4. I'm just going to have one rectangle, and I need the value of the function halfway between 2 and 4, and that is the point 3. So that gives me that value there. I'm going to highlight that value in yellow, so now I can see that how I've divided up the interval between 2 and 4. There's my midpoint. For M2, the value of h is 1, because I now have two rectangles, one going between 2 and 3 and one going between 3 and 4. So I need to multiply by the value of the function halfway between 2 and 3, which is 2.5, and halfway between 3 and 4, which is 3.5. And the colouring of that line with 3 in it makes that easier to see. And I'm going to colour that in green and colour these values in green, so that it becomes obvious that I've used those particular values. I now want M4, and in this case I've got 4 rectangles, each of width a half. First one between 2 and 2.5, the second one between 2.5 and 3, between 3 and 3.5, and 3.5 and 4. And I need the function values at the midpoints, so 2.25, 2.75, 3.25 and 3.75. And I'm going to colour those in blue. So let's colour in all the cells that we've just used. Now to calculate M8, the value of h is 0.25. We have a rectangle going between 2 and 2.25 and so on and so forth. So I now need the function values at the midpoints. So we've got that one, 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 and that one. And that now gives me the final function value. So that's M8. I'm going to calculate the differences and also the ratio of those differences. So the difference is going to be this number, take away this number here, and I can just copy that ratio, that difference down. I'm also going to look at the ratio, and I can copy that ratio down. Now let's have a look at this column here. It looks like the midpoint rule estimates are increasing. Well, let's see if that makes sense given our function. So if I select all my function values, use the chart wizard, select XY scatter graph, and select that particular subtype there, then if I graph it, I have a function which moves in this direction here, and it should be easy to see that trapezium rule estimate should be an overestimate. So for that reason we expect the midpoint rule to be an underestimate and the values to increase, which is what we do see, which is why these differences here are positive.